So this question says, could you prove that sine of x divided by tan of x plus cos of x is the same thing as 2 times cos of x? So before you've done some work simplifying when you had a bunch of sine, cos, tan, secant, all those kind of trigonometric terms, and you would simplify it down as far as you could possibly go. This actually tells you what your answer needs to simplify down to. So I'll just rewrite that out. We have sine of x divided by tan of x plus cosine of x. And you know that that needs to equal, when you do some work, you actually already know that the answer needs to equal 2 times cosine of x. So if you can think ahead, you're just simplifying this and trying to show that your answer is going to be 2 of cosine of x. So if I start to work things through, one of our strategies was if things aren't all in sine, cos, one of the strategies is to turn everything into sine and cos. So tan, according to my reference sheet, so remember this is a reference sheet that you are allowed to have on your quizzes and your tests. But tan is one that we should know already anyways. But if you forget, that's okay. Tan is sine divided by cosine. So instead of writing tan, I can just write sine divided by cosine. So I still have sine on the top, sine x, divided by, instead of tan, I'm going to write sine of x over cosine of x. And I still have plus cosine of x. Now, it looks like it's getting more complicated, but remember we start to cross things off and it will actually get simpler for us. If ever you have something like this, when you have lots of fractions, like a number divided by a fraction, my suggestion is to write that out with the division sign so you can actually see what's going on. So sine of x, this big fraction line just means divided by sine x over cosine x. And I still have plus cosine x on the end. With fractions, if you're dividing by fractions, remember you take the second piece, you flip it over, and then you just multiply across. So we're taking a fraction and dividing by it. So instead I'm going to change this to multiplication, and I can do that as long as I then flip the fraction. So instead of sine over cos, it becomes cos of x over sine of x. So if I have cos of x and I'm multiplying it by sine of x and dividing it by sine of x, really I'm doing nothing. And those two things can just cancel out. So I am left with cosine of x from here plus cosine of x from here. So I have a cosine of x plus another cosine of x. So that just equals 2 cosine of x's. So through this process, I've proven that this here actually equals 2 cosine of x. So I have proven that identity.